Here is where we take your questions and go over any of the slides that we've gone over before.
Monday, please go ahead. You can unmute yourself. Daniel, please go ahead.
Okay, so while we're waiting for them to go ahead, someone just typed in, what is ANOVA in full? ANOVA is analysis of variances. That's ANOVA. I believe for Nuhu Abdullahi, I believe we've discussed the equal variances. If that still did not answer that, just let me know. And then I have from Dr. Deniyi asking if there's an interpretation for the Z-score. Yes, with the Z table, you can make that interpretation. The Z table allows you to be able to convert this into probabilities or into p-values.
Hello, sir. This is Sam.
Yeah, good day.
Yes, so my question is from the first example. You got a p-value that was greater than the significance level, but then you proceeded to reject the null hypothesis. I wanted to know if there was...
Sorry, so let's go back to that.
Okay.
Thank you very much for drawing us to this. Yes, thank you for drawing us to this. You're right, and please let's correct whatever I have said at this point, right? So because based on, like you rightly pointed out, going with this p-value, we cannot reject the null hypothesis.
Oh, okay. So
thank you very much for that.
Hello. Good evening, good afternoon. Hello?
Yeah. Yes, I'm listening to you.
Yeah, sir, I thank you for the presentation. It was quite informative. I attended a presentation somewhere time last year. Then the person presented the research. It was a kind of educational intervention where the lady has two groups and she administered the interventions like 3 times. So when she actually reported that she applied ANOVA, and at the presentation, some people queried that because she has 2 groups, despite repeating the intervention, generating outcomes 3 times, she shouldn't use an ANOVA. So I'm just thinking, is it possible in that case to use independent sample t-test since there are 2 groups, even though the measurement was taken 3 times between the 2 groups?
So, okay, so it depends on exactly what you're comparing. Remember, this is comparison of groups, right? So if what you're comparing is the 2 groups in question, right? You took 3 samples from each of these groups, and you got a mean of these 3 samples for one of the group, and you got a mean for the 3 samples for the other group. You end up with still comparing 2 things. A mean of 3 observation versus a mean of another 3 observation is just 2 groups. So that's amenable to a t-test.
Okay. Thank you very much. Thank you.
Good evening, everyone.
Good evening.
Thanks for the opportunity, sir. Actually, I have 3 things to say. First is that, is there any way we could determine if equal variances are assumed or not using SPSS? You know, with independent sample t-test, one could easily determine if equal variances are assumed or not through the outputs. Is something like that possible with ANOVA? Can I continue with the questions?
Go ahead, please.
Secondly, is more of like a request. Please, can you like summarize the concept of one sample t-test, like in just like 30 seconds or 1 minute? And thirdly, I think in the course of explaining one sample t-test, independent sample t-test, peer sample t-test, I think something was missing, sir, and which was the type of data that each test deals with. The group we are talking about, does it have to be a nominal data? Does it have to be an ordinal data or ratio or interval data? Which one are we really concerned with when approaching these tests? I think that is also important, sir. Thank you, sir.
So before you mute your mic, let me ask you, of all the data you just mentioned, which of them would you use a mean for?
Which of them?
Will you use a mean? Which of them will you calculate mean? Average, which of them will you calculate a mean for?
Interval.
So that should answer your question. So you remember, we're talking about the slide is aptly titled comparing means. And I moved that one step further to say comparing groups, right? And our focus being groups where the distribution can be determined to be a normal distribution. And if you remember, we say that when it's determined to be a normal distribution, that we usually favor using the mean as the preferred measure of central tendency versus using the median or the mode. So today's session has all been about mean, using the mean as a tool of comparison of different groups.
Okay,
so
actually,
go ahead, please.
I'm sorry, sir. Why I asked that question was about the last speaker, the issue raised by the last speaker regarding a seminar he attended where the facilitator sampled the opinion of a certain respondents 3 times and used a particular test, and it was challenged. Actually, to me, I have the answer to that, but I'm just trying to like consider others.
Can you share the answer with us, please?
Can I?
You said you have the answer to that, so I'm asking you to please share the answer with us.
Actually, in my opinion, since something like that was done 3 times, ANOVA is not applicable.
Okay.
And in my opinion, though I stand to be corrected, is that paired sample t-test seem appropriate. For instance, one can compare the first, like, let's say P1 with P2, then P1 with P3, like that. Since the option for paired sample t-test, you can have variable 1 and variable 2 as many as you want. That's my opinion, sir.
Okay, so okay. Remember when we talked about paired sample t-test, that it has to be a commonality between the 2 groups that you are comparing. There has to be something relating those 2 groups. If there's nothing relating them, you make the assumption that they are independent. Now, from this quest, from what was shared with us, we don't know that there's anything relating these 2 groups. All we are told is that a certain researcher had 2 groups and she sampled each of those groups 3 times. What is the appropriate test to use? I go back to say it depends on what are you comparing within the 2 groups. Are you comparing means? If you're comparing mean, my assumption would be that this researcher took a mean of those 3 samples, right? And now have a mean for group A, and then they took a mean for the 3 sampling for group B, they now have a mean for group B. And they are trying to compare the mean for group A versus group B. Now, if we do not know that there's any any dependency between these two groups, the appropriate test here will be the unpaired or the independent t-test.
Okay, I'm with you, Sam.
If I may come in.
Please go ahead.
Okay, actually, it's kind of clinical trial. She tried to evaluate the impact of its RCT, randomized control trial. She tried to determine the impact of educational intervention on the major depressive symptoms among people in Maiduguri. So what she did was she asked a group that she intervened and the other group that without intervention. So she took measurement on the educational level at 0, at time 0, at 3 months, and at 6 months. That's what actually happened in the study. So she actually went for ANOVA, and some people were of the opinion that she should have used independent sample t-test, looking at the two groups only. While the other person that just spoke, and some people were of the opinion that she should have used ANOVA since she took the measurement of the educational, the impact on the education, the scores they got from the test she administered on them. So since she took it 3 times, some people were of the opinion that she should have used ANOVA. That was what confused me. I don't know what they concluded since it was just a seminar I attended.
So if you look at the slide in front of you, we talked about this, during today's session, right? About randomized control trial where we have 2 different groups who are receiving 2 different treatments. So what does that say? Independent sample. The intervention we're having in them is different. And that takes us to the independent sample t-test. It doesn't matter how many observations we draw from each group, right? Because at the end of the day, we end up having a mean for group A and a mean for group B, right? And we are looking at the difference in those means. So let's go on to other questions. I think before we go on, I think somebody is asking if they could speak. I believe that's Shamsuddin Yusuf. Shamsuddin, you can speak, then we'll round off this and take other questions. Shamsuddin Yusuf.
Yusuf, right? Okay. So Shamsuddin, you can talk.
Hello, can you hear me?
Yeah, we can hear you now.
Okay, thank you for the opportunity. From what has been said, I'll say there is some kind of, let me say, the confusion with the use of terms. The person that bring up the topic, he was mentioning about, I think he's using misconception of what we call variable and also groups, because obviously from what he said, there's just one group, but different variables, because he said they take the test at different point of time. He used an instance of at the start at 3 months, but it's still within same people, which it means it's just one group. So which means in this case, the best test to use is the independent, or rather the t-test, but ANOVA is not the real deal. Yeah.
Thank you, Shamsuddin. We'll move on, but just one comment before we move on. If it was the same group, then we'll really be talking about the dependent t-test if it's the same group, right? But if it is 2 different groups, we'll be talking about the independent. So, and I believe that the person who spoke talked about 2 different groups, which was why we were talking about the independent. But either way, yeah, the suited test here is the t-test. So let's take other questions. I think I see a hand up. Badru Lawal. If you have a new question, Badru, you can go ahead.
Hello. Hi.
Hello.
Hi.
Yeah.
Okay. Please, I wrote a question on the comment section. that I want you to please help me shed more light on data transformation, since you made mention that non-parametric tests are not as powerful as the parametric testing. So I'm a little bit confused on data transformation. I know of them theoretically, but applying them is a little bit much more difficult. And also there is this two-way ANOVA. Is there a non-parametric analog of two-way ANOVA? Thank you.
Okay, so most of your questions are outside the scope of today, right? But generally speaking, for all the parametric tests, they are non-parametric equivalents. Now, if sample size is not an issue, right? There are scenarios where the researcher might decide to do data transformation like you're referring to. And the most common transformation that most do is the log transformation, where you transform the data into the log equivalence of them. It normalizes the data, and then you move on to make to do your analysis. So, but again, that's outside the scope of today's discussion. I see that Badru Lawal still has his hand up.
Yes, sir. My own observation is that I feel the person that did a test on a particular group of people on 3 different occasions, I think it's looking like a peer T test, because this is the same group that is being tested over 3 months, then another 6 months again. So I think it's more of a paired T test, but in this case, it's happening 3 times, not 2 times as we used to know. Because now you are checking maybe the mean of educational level at start at 3 months, and the same group of people, but at 3 different times. It's looking like a paired T test, not an independent, because this is not a 2 different groups, and we are not comparing with a standard, which is as in 1 sample T test. But this is a group of people over at 3 points in time. So I think it's a paired T test, but I don't know. Since it's over 3 times now, I don't know, is it still paired or is thrice T test? I don't know. But it's the same group of people. It's looking like a paired T test, but on 3 occasions. That's just my own observation. Thank you.
Okay, so to clear this up, if you take the same measurements on the same group of individuals, right, you're talking about dependency in the sample. So yes, it will be a paired T test. But if you have a different group of people who you also take a similar measurement on, then it becomes the independent T test, right? But at the heart of it, remember, with the T test, what you're doing is comparison of means between the groups, whether it's a dependent group or an independent group, right? It's comparison of means. So, and whether you take you come in and take your test 4, 5, 6, 7, or 1 million times, as long as you come in to take the mean of those means, right, you still end up with 1 mean value for that group that you're comparing. Now, if you does that help to explain?
Yes, sir. Yes, sir. So it's a paired T test. It's a paired T test. I think so. Thank you, sir.
If what you're comparing is measurements that was done on 1 group of individuals at different times, so yes, it will be a dependent one. The next person we have here is Favor Anyao. Favor, you can go ahead with your question, please. And please, let's focus our questions on the scope for today's session. There will be a lab session that deals with what we've covered today. There will be a lab session for SPSS, and there will be a lab session that uses R. So those lab sessions will go into further details, not just with demonstrating how this is done, but talking about the criteria and the possible ways in which you can do them either in SPSS or in R. Any additional questions?
Yeah, I think we've answered all the questions. I can't see any hands raised again.
Okay.
So thank you everybody for coming around. We will send out the recordings after the class, and hopefully we will meet at the workshop again. I think there's the last one coming in.
Yeah, just let me see that.
Can you see it?
Okay, yes, I see it. I'll go ahead and read that. It says, please, I need more clarification on what you mean by groups and variables. I am carrying out a research among pregnant women, and the study is carried out in more than 2 hospitals within a state. So I take it that the groups is the pregnant women and the variables are the parameter. What types of analysis is best suitable for my analysis? Okay, so So it depends on what you're trying to measure here, right? So you may decide, because you have more than 2 hospitals, your groups may be your hospital, and maybe you're looking at the blood pressure of this of pregnant women in hospital A versus blood pressure of pregnant women in hospital B, or your group may be your pregnant women, whereas you're looking at, okay, all the pregnant women, irrespective of the hospital where they are, as being one group, right? And then you're taking a parameter to look at, okay, you're looking at what their blood group or blood sugar or presence of edema or not. So there are many possible variables, right, that you could be looking at. So at the end of the day, what becomes your main group depends on how you frame your study, right? And in some studies, you might even go ahead to, even after framing what your main group is, to even do within group analysis, you know, where you stratify by another variable. So it depends on, if your focus here is the pregnant women, then those pregnant women will be your main group. It doesn't stop the hospital from being a group. The hospital could still be a subgroup. Now, the variables are those measures that you're looking for, right? That's of interest to you. Does that answer the question? I would assume it does. Okay, thank you. So once again, thank you everyone for this. The recording will be shared, and also the updated slides will also be shared. So, and remember, there will be labs, and I encourage, participation in the labs, because there you can follow and you can do those analysis along as it's being done. Thank you again, everyone, for joining today's session.
And thank you, Dr. Nkezie. Thank you for your time.